Hi, this is Paula J. Welcome to another episode of Secure Hacks Weekly, and today with me is Mike. Hi.
Hello.
Mike is our specialist on database security and also infrastructure security, one of the greatest. And we've got a very interesting subject to cover because we're going to be talking about the problem that is currently within the database world that is related with a data owner and the database administrator, while database administrator is able to see the data that is processed within his own database. And is there something we can do about it?
Yeah, the classic approach was to encrypt the data, for example, using some crypto API libraries and send it already in encrypted form to the database. But you are losing lots of flexibility of the databases. And with the new SQL Server, we have a new feature that is called Always Encrypted Database. And this allows us to separate the role of the data owner and the database administrator. So basically, data are encrypted transparently to the application and sent in encrypted form to the database. So it's very secure and easy to use.
Great. Okay, so no time to lose, and let's dig in.
Hi. So today I will present you very nice feature of SQL Server. Actually, one of my favorite new features in SQL Server. This is SQL Server Always Encrypted Data. So this is the first time you can in SQL Server separate the data owner from the administrator. So the person or the group of the people that can read the data is separated from those who are administrating the database server itself. So these are on the slide. You see three different approaches for that or reasons for doing this. But let's focus on the details how it's working actually. So it is the possibility of enhanced client driver that is making the encryption for you that is transparent for the application. And the most important part, we are separating it from the environment, from the database server. So enhanced client driver is getting the plain text and it's encrypting it using the key that is encrypted inside the database, but by the certificate that is actually on the client side. So there is no possibility to decrypt the data because the key that is needed to decrypt or encrypt the data is stored in the database in encrypted form. The encryption is performed by the certificate that is never released from the client side. So the benefits of Always Encrypted is client-side encryption. SQL Server does not know the keys, actually the certificates, because the keys are in SQL Server, but they are in encrypted form. Next, the queries on encrypted data are possible with equality comparison, joins, group by, and distinct operators. This is great. And if you are performing currently the encryption on the client side with the, for example, C# code, those queries are not possible. And the most important fact is that this is almost totally application transparent. Almost because there are some limitations on it, but let's see it on really example. So we will be doing something very similar. I will be using the application that will be performing some select or update with the parameters. So without this enhanced driver, the administrator can use, for example, SQL Server Profiler to see the actual commands that are executed and the values of the parameters. So the driver will encrypt the parameters and the encrypted ciphertext will be actually presented to the SQL Server Profiler, to the SQL Server, and on this we actually cannot extract this information as we are the administrator. Only the data owner can see it. So the results are also encrypted. They are passing through the same driver on the same client. So it's decrypting it automatically and it's presenting the results. So let's see it in the practical approach. I'll be using two different machines. They are named very similar. Both are SQL. One is SQL 01 and the second one is SQL 02. But these are only the names. And I actually use this SQL 02 as my web server, and this is the client side. So from this perspective, remember, it's just the name, it's nothing related to SQL itself. This is from where I'm actually the data owner. If I go to SQL 1, this is actually the database server, and on this database server I have a database which is called cybercrime, and I'm using the SQL Server profiler on this one to trace what is happening. Let's go with just a replay template, and on event selection, let me give only one database name, it's cybercrime. So I will exclude any other queries. Okay, and let's see what is happening if I'm using currently my application. Switching back to my SQL 02. I'm having my web browser here, and let's say I'm going to edit the first employee, and I will change the social security number from various versions 0 to version 1. Saving it. Okay, this is the new version of it. No, I do not want to do the autocomplete. And let's see what is on the SQL 01. So you can see that there was some connection. I was selecting something, then there was additional information select. Oops, maybe before. Yeah, this is the update. So a little bit before, I have the update, and here you can see actually all the parameters. So even the new social number and the old social number is there. So it's not the best way to hide those data from the admin, even if the SQL Server and enforcing the connection to be encrypted. But in this case, we are tracing it from the server side, so as an admin. Okay, so let's do this and let's enable the always encrypted database. So from the perspective of the application, what we need to do? First of all, we need to use SQL Server Management Studio or PowerShell to encrypt the data. Remember, I'm connecting to SQL 01, but from the SQL 02. So this is from my server on which I'm running IIS server. Let's do this. So right-click on the name of the database, tasks, and I'm going to encrypt the columns. This is starting the wizard. Next, and I'm choosing that I'm going to encrypt the social security number, gender, and marital status. What type of encryption I want to use? First of all, deterministic is very good if we are having different data inside this column. If we have like gender, so only 2 of those, then the better is the randomized. But I will show you what is the difference, because deterministic will present the same values and in encrypted form if I'm using the same values to be encrypted, and randomized will present always different. As an encryption key, for all of those commands, I will use single encryption key. It will be called column encryption key auto 1. Of course, I can create before using it a new key, so choose the proper name for that. This key will be actually stored on the SQL Server itself, but it will be encrypted with the private key that is be part of the certificate that will be generated. This will be called auto-generated column master key. This column master key is used to decrypt column encryption keys. I want to store it in the certificate store. Currently I have only current user because I'm not running the SQL Server Management Studio as an admin with elevated privileges. So let's go there. I'm going to do this right away, not generate the script but right now to encrypt and everything and to generate the certificates. I can show you right now I have no certificates in the local computer and in the personal user store. This is the automatic generated certificate for the computer, but on the right side on the user I do not have it. It's right now generating the certificate for Windows certificate store for current user. So in a couple of seconds, I will see a new certificate on the right side. So I can refresh, and you can see it generated a new always encrypted auto certificate 1. And now it's performing the encryption of the columns and encryption of the data. And after that, the data are not accessible through the application because it's going to change the data type from, for example, social security number was varchar, now it's gonna be var binary. In local computer store, I still do not have anything on the personal certificates that is similar to always encrypted. Okay, so it's already encrypted. Let's go and see what we have with our application. I'm going to click on the employee list, and now I have a problem because its social security number property employee is a system byte, but we were expecting system string. This is because we are currently having it in encrypted form. Let me go and see with the script here. Open file, always encrypted. It's always nice to have it. So if I go and select asterisk from employees, let's see what will happen. Right now, everything is decrypted for me. This is because in the connection options, if I disconnect and connect again, I already had one parameter from previous attempts in this one. Additional. I will exclude this and connect again. The same query right now, remember to connect with the cybercrime. Let's go. Okay. And right now it will be presenting the data in encrypted form because it's without additional parameter in the connection string to decrypt the data automatically. So you can see that for the gender, when that was a deterministic encryption, it's not allowing me to see a randomized version of it. So if that was male, 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 probably this is female, female, and again male, female, male, female. I can only guess it, but probably based on the names I can get who is what. Who. So on the Marshall status, everything is different because I used the different type of algorithm for it. So let's reconnect again. Connection, disconnect, connection, connect. Options, additional parameters. These are the parameters for the connection string. Column encryption settings equal enabled. Connect. And use again the same database. And let's see if now we can do it. So I'm trying to do it, and everything is automatically decrypted. If I'm going to do the same query from different server, so from the perspective of my administrator, this is SQL1, and I'm trying to do this here, new query, paste it, and I'm executing this, close. It's going to say that it cannot decrypt the data because there is lack of the certificate. Okay, so right now I'm an administrator and I cannot see the data in it because I'm trying to decrypt it, but there is no certificate with this thumbprint. Let's go back to my application. Okay, so in my application on SQL2, remember this is my web server also. In PowerShell, I'm going to show you that I have the certificate with exactly the same thumbprint. I'm going to use the possibility of PowerShell to go directly to the certificate store. So this is like a drive. And here I have actually the possibility to print the certificate. And this is exactly the same thumbprint of the certificate. I will copy it because I will reuse it in just a couple of seconds here in different places. So I'm copying it, pasting it. I will delete the old one. Okay. And right now, what I need to do is to change the connection string in my IIS server. So in my application, let's do this with the ICE. Okay, opening it. In the connection string, which I already prepared, there are exactly the same words. And let me show you. Column encryption setting enabled. This is the new part of the connection string, which I'm adding right now. After this, it's going to try and decrypt the data exactly the same way. It will fail the same way. But to allow to do this, I need to have a certificate. If you think about the IIS server, actually the certificate must be placed not in the current user certificate store, but it must be placed for the local computer. So let me export the certificate. Export with the private key. Yes. Next. Hacks Weekly PFX. Finish. Okay. And now import it in the local computer. Next. Okay. Personal store for the local computer. Finish. Okay. So I have it. The last part to do is actually allow application pool identity under which this application is running to get to the private key of this certificate. So manage private key and add from the local SQL IIS app pool default app pool. Check name. Okay, this is correct one. And allow only read the private key, do not allow full control. Okay, we are almost there. The thing to do is actually that inside the SQL Server, if you go to the always encrypted keys, if we go to the definition, create new query editor of the column master key, you will see that the column master key is pointing to the current user my, and this is certificate thumbprint. What I want to do is actually create CM key for IIS server, or to tell maybe not IIS but local machine, and say that this is actually not the current user but local machine. I do not like to type, so this is why I'm copying and pasting. So create a new column master key which will be pointing to the local machine store, not to the current user to the current user store, and execute this one. The second part is that actually I need to see the definition of the column encryption key. The column encryption key is actually the key that is encrypted, and it's pointing that this is encrypted with the master key of CM key auto. Now I want to have it with two different values. One will be with the column master key, which is pointing to the user personal store, and another one for the local machine. So I already prepared that. So it will be column encryption key will be encrypted with, and let me copy this one. Okay, so I'm altering the old one with local machine. The value here is actually the key that was generated and encrypted with the certificate. So let's go add it. If you now generate the script for the column encryption key, so the real key that is actually encrypting the data, we see that it can be decrypted with this certificate or with this one. The CM key auto is actually pointing to the current user local certificate store, and this one is pointing to the local machine certificate store. The values are exactly the same because this is exactly the same certificate. Column encryption key can have up to 2 different column master keys. So if you want to change it, you need to remove one and create again additional one. So now let's see if it's possible to use the application again. Let's try to refresh. Finger crossed. It's taking some time, and now you can see it. Okay, let's see if it's really encrypted. So I'm going back to my SQL 01, on which the admin is going to sneak what we are going to do. Let's see it. I'm clearing right now the profiler and going to the IS server to see actually if my application is working, refreshing the employee list, and let's go and edit some values, for example for cat. Let's modify it, save it, and okay, it was modified, the shorter version of the social security number. Now let's go to the SQL01, see what we can see as an admin. Scrolling a little bit lower to see the update, and now it's the update. Remember, previously we've seen the values. Now we see only encrypted data. And as you can see, it is transparent for the application. So if I want to see the decrypted data, I need to actually get the certificate and put it into local computer or into the per user certificate store. This is a great feature, and I strongly recommend to look into that and have fun with it. Thank you for watching.